Well, welcome everyone to the latest edition of the Far Out Journal Club. This is produced by Rich Russin, um, and with the assistance of James Albury, Planetarium Director, and Matt Peters, a member of our club. I'm your host, Terry Smiljanich. The Far Out Journal Club is a semi-regular meeting of the Alachua Astronomy Club, located here in Gainesville, Florida. We are joined tonight by two other astronomy clubs, the Howard Astronomical League, located in Maryland, and the Tucson Amateur Astronomy Association, located out at the in Arizona, which is a co-sponsor of the Grand Canyon Star Party. Now, the goal of this club is to have a personal, in-depth discussion with with someone from cultural astronomy. By that I mean someone who is an author, artist, musician, planetarium director, observatory director, people like that who can bring us the human side of astronomy as opposed to technical presentations. Also, science fiction writers. We've had as our guests a very famous science fiction writer, Joe Haldeman, who was in the Grant Science Fiction Hall of Fame and a Grand Master of Science Fiction. We've had Tim Russ, who is a leading star of the TV series Star Trek. We've had Planetarium Director James Albury, and Yerkes Observatory Director Dennis Coyce, and also a award-winning astronomer who's written a popular book about astronomy, Emily Levesque. It is, however, tonight our pleasure to have with us as our guest Dava Sobel. Dava is an award-winning writer. He's written many books. Many of us here in the club have read several of them. She is a science writer. She's a graduate of the Bronx High School of Science. And the reason I bring up her high school is it happens to be have more Nobel laureates as graduates of that secondary school than any other school in the world. So maybe there's a Nobel Prize in the future for Dava as well. After college, she became a science writer. She written for New York Times and several other magazines, and then she started writing books. Before that, by the way, she also helped on the TV series Cosmos, produced and presented by Carl Sagan, who we'll talk about a little bit later. But she has written several books, and let me go ahead and share them right now. These are just some of her books. She wrote her first big bestseller was Longitude, a book about the search for a chronometer accurate enough to measure longitude in the open sea. She also wrote Galileo's Daughter, which is a Pulitzer Prize nominee book based upon letters that Galileo exchanged with his daughter, a nun in a convent, which really brings out Galileo's personal life. She also recently wrote The Glass Universe, how the ladies of the Harvard Observatory took the measure of the stars, which we'll talk about, and also The Elements of Marie Curie, how the glow of radium lit a path for women in science. These are just some of her books. Now I'm sharing. Now, she is the recent recipient of the 2025 Cosmos Award for Outstanding Public Presentation of Science. Now, that's not an award, it's given by the Planetary Society, but it's not an award they give out every year. They only give it when they feel someone truly deserves the award. Past recipients have been Neil deGrasse Tyson and Stephen Hawking. I'd like to read from the presentation language of the award. This is from the Planetary Society. Dava's writing stands as testament to the power of storytelling in science. She shows us that the universe is explained not just through equations and experiments, but through human stories,
That's good.
making
Thank
dis
you.
Yeah,
making
that was
distant
good.
historical figures breathe again, and allowing us to
Come
see
up with a
science
recipe
through
for
their
soap.
eyes. Looks like we're getting some interruption. Through their eyes and feel their wonder. Now, you must be personally grateful to have received this award from the Planetary Society, Dava, particularly since Carl Sagan was one of the founders of that society. Can you tell us a little bit about your personal connections with Carl Sagan?
Yes, he's really the reason I do what I do. In the early 1970s, before he was famous, he was on the faculty at Cornell, and I was working at Ithaca College. And he came to campus to give a public lecture, which I attended. And I remember sitting in the audience thinking, this is the most interesting material I have ever heard. And he was talking about the likelihood of finding extrasolar planets, other planetary systems, and showing diagrams of what the architecture of those systems might look like. And I realized later they looked a lot like our planetary system. And now that we've actually found others, most of them really don't look like ours. But at the time, it was a concept that most people were not even thinking about. And very shortly afterward, I was asked by one of the local newspapers to interview him. And he agreed to be interviewed. And I really didn't know much about astronomy, but as you probably know from reading his books or watching Cosmos, he was a masterful explainer. And I wrote up my story that night and I called him the next morning to read it to him to make sure I had the facts straight. And he corrected a few things, but he was really grateful that I had taken that step. So then we chatted a little and I said that I was applying for the science writing job in the Cornell News Bureau. And he said, oh, would you like me to write you a recommendation? And as I said, everything started from there.
Okay, great. And then you actually had a chance to work on the Cosmos series itself, didn't you?
Yes, not really on the series, but he wanted someone to accompany the crew on location so that if people watching the filming had questions about the astronomy, somebody would be there to answer their questions. And by that time, I knew enough to do that. And we really didn't get a lot of questions from people who came to watch, but my great moment occurred. The filming in Greece included a scene at an outdoor amphitheater, and there was a fire down in the center representing the sun. And then each of the steps in the audience had a flag for one of the planets. And I got to the set early and noticed that Saturn came before Jupiter, which really would have ruined everybody's day. So I was able to get that switched before he showed up, and everybody was happy.
Great. Well, it's a good thing you were there. Now, your books are really about the history of science, different
Yes,
chapters in the history of science. And we all think of science, or a lot of people think of science as this never-ending series of successes, and great triumphs that lead us higher and higher. But your books bring out the fact that really the pursuit of knowledge is a painstaking struggle filled with many failures along the way. And your books are filled with, these scientists that didn't just reach overnight fame. They had to struggle and struggle and struggle. I think that's a common theme in your books. So let's talk about some of them. First of all, we'll talk about the later books because we could devote a whole program to each one of your books, honestly. But we don't have time to do that. So we're going to concentrate on the most recent ones. But let me go back to Longitude because when you decided to write that book, I hear that some of your colleagues and family were a little skeptical about a book about longitude. Is that right?
Oh, yeah. Yeah. It sounded completely daft. Who would want to read about that? And and my son used to ask me all the time, "Do you really think anyone will read this?"
Right.
And I wasn't sure, but I was really having the time of my life telling the story, and he understood that.
Right. And it turned out to be, in fact, a great success. I mean,
Yeah.
how many editions have there been of it? Do you know?
I don't know
Okay.
how
Well,
many, yeah, but it's been translated into many foreign languages. Even it's 30 years old and it's still in print, which
right. And of course, it's about, of course, the particularly John Harrison and the search back then for, finding out where you are at sea when you're not in sight of land, and you can find your latitude pretty easily with, with the sextant and the sun, but finding out what your longitude is was a challenge for sailors for millennia,
yeah,
and they needed. He came along as a clockmaker who made better and better clocks or chronometers until he finally got one that won him a prize, which he had to struggle to get, and all that. But one of your later editions, I noticed, had a foreword by Neil Armstrong. I
yeah.
must have pleased you. That happened.
Well, it was a 10th anniversary edition, so the publisher wanted to
Recording in
do
progress.
something special and thought that it would be good to have a foreword by someone important.
Hmm.
I immediately thought of him because when they came back from the moon, they they made a world tour. And when they were in England, they dined at the Prime Minister's residence. And Neil Armstrong toasted Mr. Harrison as being the one who had started them on their journey. So I
Wow.
knew he knew the story and that probably he'd received the book as a gift, maybe from a few people,
Yeah.
because it was the sort of book that you gave to a man
Right.
who didn't need anything else.
Right.
And I knew if we could get to him, that he would probably say yes. But he
Right.
was very private, and no one really knew how to get to him. And
Right.
then he he authorized a biography, and the person writing the biography, whose name escapes me at the moment, approached my agent for help with the foreign rights. And suddenly a path opened to Neil Armstrong.
Wow.
So I wrote to him and he agreed right away.
Wow. Well,
That was a thrill.
that
Yeah.
was great. That was great. Now, when you were writing the book, you write in it that you had an opportunity to go to the Royal Observatory in
Yes,
Greenwich and actually stand on the prime meridian. Did that help bring the book home to you?
yes. And at the beginning, I really didn't think I'd be able to go to England, had a tiny advance. And as I was writing it, one of my older brothers came to visit, and he just loved the story. And he said, if if you can't afford to take a trip to England, I'll send you.
Mhm.
So then I realized it was definitely worth going.
Right.
He said it'll be a different book if you actually go there,
Right.
and I knew he was right. So
Right.
that it wasn't so much standing on the prime meridian, although that is a direct result of the events in the story, but it was seeing Harrison's clocks, the progression from the first one to the final piece, and just watching them move. They're very beautiful, large objects. They're really like moving sculptures. And,
Wow.
and the works are exposed and they're all running. So, so you see this very unusual clockwork, and the sounds they make are unusual. So all of that was just thrilling
Right.
and
And
emotionally stirring.
I bet it was. And the final result, the final clock that he came up with, the chronometer, is actually pretty small, isn't it?
Yes, yes, it's about 5 inches in diameter and it weighs 3 pounds.
Wow.
Whereas the earlier ones stand 2.5 feet high, and they weigh in the neighborhood of 80 pounds.
Well,
So,
so they're easy to take on a ship. And so before GPS came along,
well,
ships
GPS is
finally knew.
the direct
Yeah,
descendant of the rival methods from the 18th century. Yeah,
that's right. But even before that, though, sailors finally knew where they were.
yes,
Yeah.
yes.
Now, the book won an award that has got one of my favorite titles, the 2004 Harrison Award from the Worshipful Company of Clockmakers. Now, how many people have won an award from the Worshipful Company of Clockmakers?
Not many, no.
No.
Yeah, that was really meaningful as well, because that was the guild that was in place in Harrison's time.
Hmm.
The guild goes back, I think, to the 1600s.
Wow.
So, yeah,
So I think probably the Worshipful Company were also very, very pleased when your book came out, because they finally had a whole book, a successful book written about making clocks.
yeah, yeah, they were very friendly.
Now, before we move on to your latest books, I want to go back to the book you wrote on the planets. Did Pluto have its own chapter?
It did.
It did. I'm
It was
glad it did.
already threatened, but it had its own chapter, yes.
So, what part did you play in the ignominious ouster of Pluto from our 9 planets?
So I was on the planet definition committee. So once extrasolar planets began to be discovered, and bodies in our own solar system that were in the neighborhood of Pluto in the Kuiper Belt, there was a real question about how to define new discoveries. And the International Astronomical Union wanted a solid definition. So planet is an ancient word. It just means wanderer. And it distinguished the planets from the fixed stars. But something more specific was needed. And there was a committee of planetary scientists that worked on this for a couple of years, but there were too many people, and they never really met in a room and fought it out. So the IAU decided they'd put together a small committee and put everybody in a room for 2 days. And we would have to come up with a definition.
Right.
So because of that book, I got chosen to be on the committee. And I was the only non-scientist. And I remember my other brother said to me, "Why did they want you?" And part of it was this sensitivity to the popularity of Pluto.
Hmm.
So Owen Gingerich was the chairman of the committee, and people had very different ideas at the beginning, but everyone heard everybody else out. It was cordial, civil, and we came up with a definition that included Pluto. Our definition said that a planet was an object in orbit around a star and massive enough to have shaped itself round. And some people didn't like that definition because it made more than 9 objects planets. Charon would also be a planet. Some of the new Kuiper discoveries, I think even Ceres was a planet. And somebody actually said that children wouldn't be able to memorize that many objects. And I thought that person has never been near a child because, if they're interested in something, they
Right.
memorize a great deal. But then so the executive committee approved our definition, but then it came up for vote at the General Assembly in 2006. And that's where a third criterion got introduced. This idea that to be a planet, the body had to have control in its orbit. And that's where Pluto
Right.
fell out.
Right.
And so it is no longer considered a planet. But the real tragedy of that definition is that it doesn't work beyond our solar system. It's even defined in terms of the sun instead of a star. So
Right.
to me, the whole point got
Right.
lost.
Well, I think Pluto should have been grandfathered in, frankly.
A lot of people agree with you. And the scientists on the New Horizon project all said they were glad that the spacecraft was en route before that happened because they feared it might have been canceled.
Wow. Yeah. Okay. Well, let's move on to your recent book, The Glass Ceiling. Let me.
I'm gonna stop you right there because
Yep.
it's really called The Glass Universe.
I'm sorry.
No, and that was intentional. I mean, when I chose that title, I thought this is great because
You
it
know,
describes the collection of glass plates at Harvard, but it makes a reference to the concept of the
yeah,
glass ceiling, and this is a story about women astronomers
yes, I was
who go only so far.
right. That's funny because of course, I know it's the glass universe, but every time I see it, I keep seeing the glass ceiling.
Yeah,
I'm
yeah.
sure I'm not the first person to have done
No,
that.
you're not. In fact, the publisher calls it the glass ceiling all the time.
Okay, well, I pulled up a picture of the Harvard women, or at least one picture of them that shows some of them. Tell us a little bit about who they were and what they were doing.
They were, they started out being members of the observatory family. So the wives, children, sisters of the resident astronomers. But at the time, photography was just being introduced to astronomy. The director of the observatory started a project to photograph the night sky all through every clear night. And he had an opportunity to partner with someone who was interested in photographing the spectra of the stars. So there were several kinds of photography going on. Chart plates that would help people really map the heavens, spectrum plates that would try to determine the composition of the stars, photographs of comets, asteroids, whatever they could get. And with the speed with which these glass plates accumulated, there was a need for people to study them and make different kinds of analyses. And Pickering believed that women could do that work. And so he hired, and he could get 4 women for the price of 1 man. So it was an economical decision. And they were doing things like trying to figure out a classification system for the stars based on the spectra. They're just looking at the spectra, seeing patterns that looked similar, and creating classes. And in that photograph you showed, the woman who was standing in the middle of the room, she created, so yeah, her name is Williamina Fleming, and she created the first system at Harvard. It was an alphabetical, excuse me, an alphabetical system in alphabetical order. And she classified about 10,000 stars. And Pickering, who's standing at the back there, published her work in the Annals of the Observatory. And she made many other discoveries because looking at the plates, you could see things change over time. She discovered a number of novas. She was very interested in variable stars, discovered a number of those. And then let's see if I can use my cursor as a pointer. Does it show up for everyone?
No.
No. Okay, well, just to Pickering's left, there's a woman seated near him with looking at a plate with a magnifying glass. And
Okay.
that is, no, not in the front, but that one, yeah. So that's Antonia Mori, and she was the niece of Henry Draper. And Henry Draper was an amateur astronomer who began this huge project to photograph the spectra of the stars. And so she came to work at the observatory, and she modified Mrs. Fleming's system, made it much more complicated. And it was left to a third woman who is not in this photograph, Annie Jump Cannon, to distort the alphabetical order, but really come up with a system that held together. Here, so Miss Cannon is, if you can see my cursor, she's the elderly woman sitting closest to the globe, not sitting on the floor. That one, yes. So that's Annie Jump Cannon, and she is the reason that we memorize the categories of the stars with the mnemonic, "Oh, be a fine girl or guy, kiss me."
Right.
That was her work, and because no one knew what the organizing principle would be, and it turned out to be temperature,
Right.
which was not known at the outset.
I'm sorry. And was I didn't mean to jump. Was in this picture or the other one is Henrietta Leavitt shown?
She is not in either photograph, unfortunately.
Tell us
She
about her.
She was home ill when that photograph was taken, and by the time this one was taken, she had died.
Okay. And tell us about her. What was her?
So Henrietta
discovery?
Leavitt was not involved in the spectral work or the classification work, or the chart work, mapping the heavens, but she was specifically looking at the relative brightness of stars, hunting for variable stars, and being able to codify a brightness scale for measuring all the stars. And because she was given photographic plates taken in the southern hemisphere, she discovered a couple of thousand variable stars in the Magellanic Clouds. And because she could assume that all the stars in each of the clouds were roughly the same distance from Earth, then she knew that all of those, that whatever variables looked the brightest really were the brightest. And she further noticed that the brightest stars took the longest time to cycle through their changes. And she published that fact. And Pickering referred to her observation as a law. And in recent years, astronomers have started referring to the period luminosity relationship as the Leavitt law.
And this was important because it showed what? It showed that the Milky Way was not the universe, right?
Well, not yet, but her findings about variables were used by Hubble to prove that the Andromeda Nebula really was a separate galaxy. So she was involved in that discovery as well. But what she did was establish a distance, a way to measure interstellar distances, which hadn't really existed before.
Hold on a second. I'm trying to get back to my screen sharing. I'm sorry. Well, anyway, let's move on. Now, one of our previous guests was Dennis Coyce, who's director of the Yerkes Observatory, and they have in their library like uh, uh, 1,700 glass plates dating back to the 1890s. It's the second largest collection of glass plates, but the largest is actually at Harvard, where these
Oh, yeah,
ladies
the
were working.
Harvard collection was about 500,000. Yeah.
And tell us why would a glass plate from, let's say, 1910, showing a little piece of the sky, why might it become important?
For time domain astronomy. So modern discoveries in that region of the sky, people would like to look back and see if there was any evidence of that in earlier photographs. And that was Pickering's vision, that you'd have a whole century of the sky preserved in these plates. It was a remarkable undertaking. Many of the chart plates have been digitized.
Right. Now, tell us how the writing of this book, The Glass Universe, how it led to your latest book, The Elements of Marie Curie.
Yeah, so this is a story of women in astronomy, and I chose it for that reason. I first heard about Henrietta Leavitt from Wendy Friedman when she was in charge of one of the key projects for the Hubble telescope. And she said, well, we're using these Cepheid variable stars, and whose screen am I seeing? Is this?
I'm sorry. I'm
That's
trying to
okay.
get back to my original screen, and everything was going fine, but I don't seem to be able to get back to my original Zoom screen. It's not showing up for some reason. So just ignore
Okay, I don't know what to do to
go right
help you.
ahead.
Sorry. Yeah, so Wendy Friedman told me we use these stars called Cepheid variables.
There it is.
There we are.
Yeah.
And and the whole idea of using these stars goes back to a woman who lived 100 years ago. And that was really interesting. So I wanted to learn more about Henrietta Leavitt. And the first thing I learned was that she was in a whole room full of women at Harvard, which was astounding to me because Harvard was never known for being friendly to women. So I began writing this book, and I had the very disconcerting experience of being constantly surprised by what the women had done. And I finally had to admit that I had very low expectations of them. And that bothered me. It was because it was a kind of misogyny. Why did I have these negative attitudes about women? I'm a woman myself. And I could only conclude that I had absorbed a lot of the negative attitudes that were in the air around me as I was growing up in the 1950s. And even when I applied to the Bronx High School of Science, we were all told that boys would be admitted preferentially over girls in a ratio of about 4-1. And nobody thought that was odd or unusual or unfair. It was just the way things were. So, so there was this part of myself that I had never recognized before. And that really changed me and made me want to tell other stories about women in science. And my publisher immediately suggested a new biography of Madame Curie. And I said, no, I don't want to do that. She's too famous. Everybody knows about her. And I don't have anything new to say. But then I was invited to review a book about women chemists, a book called Women in Their Element. Very clever title. And it was a collection of essays about some 30, 35 women chemists. And of course, Madame Curie was one of the profiles, and her daughter Irene was another. But then there were all these other women, and at least half a dozen of them mentioned an important formative period in Madame Curie's laboratory. And that stopped me. Because we always picture her alone or with Pierre. And there was what seemed to be a network of women in her lab. And I thought, well, if this is true, this is really a story, because nobody knows about this. So there were 45 women who passed through her lab, which I found really, really fascinating.
Yeah, well, Marie Curie, is that showing up?
Yes.
Yes. Okay. Marie Curie was, of course, a remarkable woman. I see what I have to do. Let me do this. Here we are.
There she is.
Yeah,
Yeah.
there she is. She was a remarkable woman. Tell us how she became so important to 20th century physics and chemistry.
Yeah, she was dogged and determined because she grew up in Warsaw, where women were not admitted to university. But she figured out a way to get to Paris and go to school. And she excelled, even though she was a foreign student. She was first in the exams her first year, which was an advanced degree in physics. And then she got a second degree in mathematics and came in second in the whole class. And she showed so much promise that one of her professors got her an actual job of analyzing steel for the French steel industry, trying to figure out which recipes for steel made the best magnets. And in the course of that work, she met Pierre Curie. They fell in love and got married. And then she wanted to work towards her doctoral degree and chose a topic of interest to her, but not to too many other physicists. And this was the idea of uranic rays, something that had been discovered in 1896 by Henri Becquerel. Some strange power coming from uranium and uranium compounds. And the world of physics was so caught up in X-rays, which had been discovered just the previous year in 1895, that nobody was paying attention to the uranic rays. So she thought that would make a very good topic for a dissertation. And some instruments that Pierre and his brother had invented gave her a way to examine materials looking for these uranic rays, which she eventually renamed radioactivity. And in the course of this work, she sensed that there were as yet undiscovered elements in uranium ore that were highly radioactive, more radioactive than uranium itself. And Pierre joined her in the work. because what she was doing was more interesting than what he was doing. And together they discovered two new elements, polonium and radium. And they became world famous. They shared the Nobel Prize in Physics with Becquerel. So she was the first woman to win a Nobel Prize. And they were on the brink of all great things. But only 3 years after that, Pierre was killed in an accident. And that left her at 38, the mother of two young children, and probably no future, except that the Sorbonne, where Pierre was now teaching, realized that she was the best person to take over the laboratory where they had worked together. And they offered her that job, and they also offered her his physics professorship, which made her the first woman ever to lecture at the Sorbonne. So now she's world famous. She's a pioneer in a fascinating new arena of physics, and she's a Nobel Prize winner. Women were really eager to come and work for her.
And
And
many did.
because she was in charge of the lab, she didn't turn them away.
So she attracted many young women who were budding chemists, who she gave them an opportunity to further their careers, where they went on to their own great
Yes,
achievements.
several
Uh,
of them became the first female professors in their home countries.
yeah,
They
and
came from all over the world. Yeah.
she was also remarkable in so many ways, including the fact that she what did she do during World War
Yeah.
One?
So when the war broke out, because she was knowledgeable about X-rays, she realized this would be the first time that wounded soldiers could be X-rayed for battle wounds. And she outfitted a van. She got someone to give her a car. The first one was a car. She didn't know how to drive, but she got a driver, and she outfitted this car with X-ray equipment and took it around to hospitals in Paris and as close to the front lines as the army would let her. And over the course of the war, she personally outfitted 18 mobile X-ray units. The army outfitted even more. And she worked with her daughter. One of them would often stay at one of the mobile hospitals and really teach the people how to take and interpret X-rays. And she also set up a training program for women during the war who wanted to help the war effort. And she had a 6-week course in electricity, X-ray theory and practice, and human anatomy. And if you succeeded taking this course, you could then be an X-ray technician and go work at one of these outposts. And she had 150 graduates.
Wow. Well, I'm sure it saved a lot of lives of
Oh,
soldiers
yeah,
who were wounded in the war.
yes,
Yeah. So that's just an example where she touched so many people in so many different ways. I want to move on to uh, this photograph.
yeah.
Uh, there was a physics conference that was held not every year but frequently, called the Solvay Conference in Belgium. And this is one of my favorite photographs because this is from 1927, and it shows, I think, probably the greatest collection of minds ever taken in one photograph. Because you have in this, you have in the background, you have Wolfgang Pauli, Erwin Schrödinger, Niels Bohr, Max Born, Louis de Broglie, Paul Dirac, just
Werner Heisenberg.
all these giants of 20th century physics. And of course, in the front row, you have Madame Curie, the only woman in the audience, and she's on either side of her. She has Max Planck, probably the discoverer of the theory of quantum mechanics, and on the other side, Lorentz, who was one of the pioneers of relativity. And then, of course, in the middle, you have Albert Einstein. So you have in this photograph the greatest male scientist and the greatest female scientist of the 20th century. Now, I did all that as just a background because sitting on the other side of Albert Einstein is another French physicist named Paul Langevin. Tell us a little bit about how his connection with Marie Curie and her story.
Yeah, so he was a very good friend of hers and Pierre's, and she taught at a female teaching academy, and he also taught there. So they knew each other very well. And about 5 years after Pierre died, Paul began crying on her shoulder about his unhappy marriage. And they became lovers, having a secret affair, but the secret was found out. And there was a big scandal because he didn't leave his wife. And she was vilified in the press as a foreigner, a homewrecker. She was even attacked. A mob came to her house. And in the middle of some of the worst of this, she won her second Nobel Prize. And there was some question about whether she should go to Stockholm to collect the prize, because she didn't want the scandal to taint the solemnity of the ceremony. But they told her that nobody believed the lies in the French press and she should just come ahead. And then the newspaper coverage got more and more scurrilous, and the Nobel Committee asked her not to come. And then that really tipped her off, so she went.
Yeah, that's great. And she one of her big supporters back then, by the way, was Albert Einstein, right?
Oh, yes, yes, they were good friends. There are pictures of them hiking together, and they were on so they were in the Solvay Council together, but they were also part of a special committee formed after the First World War in the hope that the great intellectuals of the world could find a way to assure lasting peace.
Right.
And the two of them were chosen to be on that committee. So whenever there was a meeting, she was happy to see him again, and they would have some time just to talk, just the two of them.
Yeah. Now, time is running a little short, but I did want to get into a couple of other things. First of all, your genre of history of science and science writing, um, you've does it help? Do you think that you're not a scientist in writing about this?
That's a good question. Personally, my favorite books to read are the science histories written by scientists who write well. And that is a very small
Yeah.
category.
Right.
Sagan was fantastic. But he was not the only one. And I often think Stephen Jay Gould, who was teaching anthropology at Harvard, used to have his students read Darwin's Origin of Species. And a lot of them would ask, was this the version for the general public? And he wrote a separate one for the scientists because it's so well written.
Mhm.
And he would say, yeah, I mean, that's how it used to be. You would write well. I feel a need to be extremely cautious. So when I write one of these books, I put together as many people as I can get who are experts in the field, who will agree to read the manuscript and catch me out.
Right.
I make a mistake. So that's how I make up for not being a scientist.
Right. Now, you've taught science writing, I think, like at the
Yes.
University of Chicago, other places. What are the main points you try to get across to your students about this, about writing about science?
I I make them write a lot. I I remind them that anything you write is an occasion to try to write well and express yourself clearly, even if that's an email message home. I encourage them to, because several of them really want to have writing as a career. And I urge them not to think about writing for the general public, but writing to one person, a real person, someone they know perhaps, who would be interested in that story,
Hmm.
and to write the story for that person alone. Because if you, especially for a young person, to think about writing for the general public is a terrifying thought.
So who did you
It
write?
immediately gives you writer's block.
Right. So who did you write Longitude for?
My mother, it really did. My mother was really a navigator, and my father got interested in sailing. So she took courses at the Power Squadron and became a navigator. She had a sextant, she had charts. This was a very serious business for them. And I was a child at the time. I think I was about 5 when she did this. So she took me with her because it was night school. And of course, I didn't pay attention, but I was there. And and she was still alive when I wrote the book. And I knew she didn't know the history. And she loved the whole thing. And then the book is dedicated to her.
Yeah.
And it was the family joke. Again, as you said at the beginning, I didn't think anybody was going to read this book. So the dedication was to my mother, a 4-star, and her name, Betty Gruber Sobel, a 4-star navigator who can sail by the heavens, but always drives by way of Canarsie. So, if you live anywhere outside of New York, what is Canarsie? But
Right.
it's the neighborhood in Brooklyn where she grew up.
Right.
And when you say that you drive by way of Canarsie, it means you are terribly lost. No idea. And I think my favorite letter that I ever got about longitude, and I've gotten many, many letters from readers, but this was from a retired Pan Am pilot who told me that there's an approach to Kennedy Airport that's called the Canarsie Landing. And he said, and when we come in that way, we know exactly where we are.
Uh, well, time has gone so quickly here. It's such a pleasure to talk to you, and I have a million other questions, and I'm sure our listeners have their own questions they'd like to ask you. We're running a little bit over, but if you don't mind, if we've got time, uh, uh,
Sure.
Rich, have you been keeping up with any of the questions coming in over the chat line?
Yes. We just had one come in from John Pinto. What he said was Davis writing reminds me of Asimov's History of Science writing. I wonder if she ever met him. And he was also good friends with Sagan.
I did meet him. He was the commencement speaker at my college graduation. And I remember he said that he envied us because our generation was going to live on the moon.
Yeah. And then
And
Mars.
later, it didn't happen. Later, I did meet him because I joined for a while the National Association of Science Writers, and he was at one of the meetings. I don't recall now if he was just there as a speaker, maybe, or if he was a member. But his book, he wrote a book. I'm going to forget the exact title now. I have it, but it is a history of science and technology, written as a series of brief biographical sketches of, there must be 1,000 scientists described. And the whole thing is so delightfully written. I like that better than his science fiction, by far.
Okay. One question that I know is on the minds of many people is, do you have another book coming out?
No, I mean, maybe I'll get another idea, but I don't have one at the moment. But I'm hardly bored. One of the things I do now, I edit the poetry column in Scientific American. And I'm very proud of the fact that there is a poetry column, which I suggested to them in 2019, and they liked the idea. So this column is now in its 6th year, and the number of submissions is beyond anything I ever imagined. And I get quite a bit of poetry from scientists because the poems have to be about science.
Okay.
And I have had 2 Nobel Prize winners submit, and whose poems have been published in the magazine. One of them is Kip Thorne, and the other is Roald Hoffman, who was a Nobel Prize winner in chemistry. He was one of the people I asked to read my Madame Curie book because I know him for a long time. And he said no on the grounds that he really didn't know enough about the topic. But surely he knows more than I do. But he didn't feel he was expert enough. Yeah, I am open. I would love to write another book. I think I'll probably not be happy if I'm not working on something, but I don't have a good idea yet.
Okay. I do have one thing here from Benson Getz.
Yes,
Benson, could you unmute yourself and share your comment?
I think I am unmuted.
Yes, I hear you.
Dava, I was in London when Longitude was released. As I was reading the book, I was discovering London. And in one of my morning strolls, I discovered the Guildhall,
Oh, lucky you.
which most people don't even know exists. And one of Harrison's chronometers is in that little tiny clock museum that's the size of a closet.
Yep.
But what I most enjoyed about the book, and I love the way you understated it, was that because he was not a member of the Royal Society, he was never able to collect the 20,000 pound award because the scientists declared he wasn't a scientist. But his son became a barrister, and I found great amusement in that. And I
Well, they
love
did give him the money. Remember at the end, he appeals to the king, and the king pushes Parliament to give him the money, but they didn't really celebrate him as the person who cracked the longitude problem. Yeah.
but his son made up for it, I think.
Okay, Rich, do you want to include anybody else here?
I don't see any more questions in the chat window. Um, at this
Well,
point in time, I think because we've gone over, we could probably wrap it up.
yeah, I think so. It's 8 o'clock. Let me just say, David, we could be here all night talking about your books and the subjects they're about. It's been such a delight talking to you. We thank you so much for giving us your time to join us here and to share your thoughts and your insights. And we all have enjoyed your books, and we feel like now we know you a little bit better as as a person who behind those books, and this exemplifies what we try to do here with this part of the club, which is not not technical presentations of subjects of astronomy, but the human side of astronomy and the human side of science, and that's what, of course, exactly what you bring to us. So I want to thank you on behalf of the club. Thank everybody else for being here and wish you well in your future endeavors. And if you do come out with a new book, we'll be the first in line.
Okay, it's Dave. Thank you.
Okay, I think that'll wrap it up then there for everybody. Thank you all for being here, and we will let you know about our next guests sometime in the near future. So thank you all very much. Thank you, Dava, and good night to all.